very warm welcome to all the audience and our panelists today. Thank you a lot for joining for today's webinar. We have a topic today which is very interesting, on which we're talking about hydrogen-powered light mobility, and we'll be exploring what the future holds for two-wheelers and three-wheelers. A bit about 𝗶𝗵𝗏𝗿. So 𝗶𝗵𝗏𝗿 is a strategic consulting and advisory company where we work broadly in energy, utilities, and all the new energy segments like e-mobility, transport, carbon, and hydrogen. We're working broadly with the service of policy, strategy, engineering, and training. Today for this interesting webinar, we have some amazing speakers today with us. We have Mr. 𝗟𝗶𝗴𝗵𝘁. He's the CEO from HyZero. He has 30 years of experience in driving global business growth, and he has led startups to IPOs. He's the founder and CEO of HyZero and has been pioneering in affordable hydrogen fuel cell solutions. He's a graduate from University of Chicago Booth School of Business. He brings deep expertise in strategy, ESG, and innovation. On the second line of panel, we have Mr. Siddharth Mayur. He's the founding and managing director of H2e Power Systems. He has been at the forefront of advancing clean energy solutions. He has deep expertise in fuel cells, green hydrogen, energy storage. He's also done a major role in developing hydrogen in light mobility applications. Along with me, I also have our managing director, 𝗟𝗶𝗴𝗵𝘁. So he's have more than 20 plus years of experience in automobile sector. He's a mechanical engineer, and he's been guiding us in our hydrogen journey at 𝗶𝗵𝗏𝗿. And I'm Yawani. I lead the hydrogen practice at 𝗶𝗵𝗏𝗿. We have been working with different governments, 60 plus countries together in developing new energy roadmaps, driving policy advocacy in the country. Interestingly, coming to our topic today, we see that globally there's a lot of stir happening in the transport sector. There's a lot of inclination and shift moving towards more cleaner and sustainable transportation. As we see that IC vehicles today still remain dominant, but the shift is increasing. In 2018, EVs were nearly 2%, but today in 2024, today we have them as 18%. Although hydrogen fuel cell vehicles have not made it to that extent, but yes, it is growing. So globally, we are seeing the shift from IC to EVs to FCVs and other vehicle segments. Globally also, two-wheeler, three-wheeler segments is seeing a growth when it comes to EVs as well. So globally, we have 13% EVs are making up to the total registrations you may call, or the annual sales that we may say. So yes, globally also two-wheeler, three-wheeler market share is increasing. When we see India's journey, so yes, India has also experienced a very exponential growth in this sector. The sustainable solutions are evolving in India. So in India also, since it's a two-wheeler and three-wheeler light mobility kind of focused country, so we have almost 80% vehicles are two-wheelers in the country. So there you are also seeing a shift in EVs. So nearly today, 8% annual sales in 2024 were attributed to EVs. FCVs were almost less than 1%, but then again, those were in the heavy duty segments. Again, I mean, in India, it is at a nascent stage, but we are seeing a lot of policy level interventions coming up, government's intentions to drive the hydrogen sector. Transport is one of the sectors, but definitely steel, cement, and other sectors are being taken into consideration. So yes, there's a potential that we are seeing, inclination of the industry and the government that we see when it comes to hydrogen. Going back, so why hydrogen? Why are we talking about hydrogen in the transport sector? So one important technological advantage that we may say hydrogen has is in its energy density. So hydrogen has an exceptional energy density when we compare to batteries. Of course, it is almost 140 times. Then from the operational efficiency perspective, if we talk, the refueling time is quite low. It's very, very low, 5 to 6 minutes. If you again want to compare it with batteries, which is 5 to 6 hours. Again, basis to its energy density, I think you get a long range in different hydrogen vehicles when it comes into picture. And one very important thing and advance, a technological enhancement that hydrogen can bring is its zero emission capability, right? So EVs today, we still talk that they are not cleaner, as your grid is not cleaner. The greener the grid, the greeners will be your EV. But in hydrogen, that point kind of we get a benefit in that area. So it's quite zero emission. So there are zero tailpipe emissions. So these are some of the technological advantages that we see in hydrogen, but we need to explore more what more hydrogen can bring to us. But yes, when we talk about these technological advantages, economics at the same time come into picture. Today we see economics are not in place for hydrogen, but as per industry experts, as per different views that we have in the industry, definitely some cost reductions, increase in more production capacities of hydrogen will definitely result in helping us mitigate these challenges. So one important challenge that we see today is the high cost of the vehicle. We talk about the transportation sector, lack of refueling infrastructure, then high fuel cost today that we have in hydrogen. Then there is also a very important concern related to the energy efficiency of the vehicles or the conversion efficiency that we call. And I think we'll discuss about in detail with our speakers when we come on these. And then we have lack of policies and incentives when we talk about the transport sector. Because this is a niche segment, because this is initial transitioning for hydrogen in the transport sector, I think policies will play a very important role going forward. Apart from that, I think hydrogen being odorless, being kind of a gaseous element, I think safety and regulatory challenges are very, very important in transportation sector as well. Our speakers will throw light on that as well. So let's see, how do we mitigate these challenges? We'll discuss with our experts. And that is where we come to our today's focus for this webinar, asking these very top level questions today, like what is the value proposition of hydrogen for light mobility applications? What are the key techno-economic considerations that makes them scalable and viable? And what are the key areas of interventions required across different players, to scale up this industry, to scale up hydrogen for light mobility applications? So over to you, Rahul, to share your brief thoughts, and then we'll move to Shekhar. So thank you so much.
Thank you. Thank you very much, Yamini. I think it was a great context setting. Two-wheelers, three-wheelers, which we calling as light mobility, they are comprising a high share, at least in India, almost 80+%. And EVs, from the greener point, from also the economics point, have started trying to decarbonize this sector. And now here comes some challenges to kind of bring hydrogen applications to the light mobility applications, right? Including P-manifold. To tell to the audience, we have done extensive work in hydrogen applications in heavy duty vehicles, truck electrifications. We have developed a roadmap for India projecting till 2050, how the trucking sectors will evolve in 21 different subsegments. Between each of the subsegments, how diesel, the new fuel, CNG, LPGs, the hydrogen, both ICE and FCV versus batteries will evolve. So I think everyone and most parts of the world, we have always looked hydrogen with applicability to heavy duty vehicle segments, including ships and maritime, right? So when I got introduced to Shekhar, Siddharth, understanding their innovations, in bringing this technology and solution and fuel source also to light mobility applications, I was really very kind of intrigued, like what makes this economics work. And thanks to them to really accept to come and share their insights, their ideas, their journeys into what they are doing today. Congratulations to you, Shekhar and Siddharth, both. They were both at Davos World Economic Forum, making their commitment and signing an MOUs for taking this application, fuel cell driven hydrogen applications in light mobility applications. And I think that's what I am really excited to learn today. The innovation that I understand that has happened, like while we are considering hydrogen benefit for its energy density, like we can pack more energy in lesser weight of hydrogen in lesser fuel. But the other trade-off of hydrogen is it takes high volume, right? And hence you have to compress it at a very high bars, 300, 700 plus sometimes to kind of get it at the right volume to fit into your truck applications. And those pressures added to hydrogen's permeability and metal reactions makes it safety hazard and issues. And that's where a lot of weight and cost gets added just in the storage technology of the hydrogen. And that's what I think our new challenges have really kind of brought innovation, like how hydrogen storage can be made easy, made economical, and plus also in a swapping system, and that to a light two-wheeler and three-wheeler applications. So I think that is what I'm very excited to hear from. So let me first invite 𝗟𝗶𝗴𝗵𝘁 from HyZero. 𝗟𝗶𝗴𝗵𝘁, this new startup, Shekhar has a multiple entrepreneurial journey. In his new startup, he's focusing on becoming a fuel cell supplier and have developed, is in phase of pilot testing, both two-wheelers and three-wheelers running on hydrogen. So let's hear from Shekhar, you, like how do we really develop this technology for a mass appeal in India market? And with this, I think if we are able to really crack it, then world is the stage for taking hydrogen to light mobility applications. Shekhar, over to you.
Thank you, Rahul, and thanks, Yamini, for coordinating. And the way I would like to take my part of the presentation forward is to basically talk about two things. Very little about my company and what we are doing. Hopefully, we'll cover that in the Q&A session. But then focus on what issues, common issues we have, because Siddharth is on the panel as well. I recently met him very briefly, in fact, across a large conference room table only. And I realized that we were both working in the same domain, and I hadn't met other people like that. So I basically want to address this as a joint, Siddharth and Shekhar presentation to the audience, so you understand how we are jointly approaching this. I see some commonalities, some competition, so I want to address that. So Rahul, with your permission, if I could go in just through introducing my company, spend a couple of minutes on that, then spend rest of my speaking time on how I see the issues and then wrap it up by saying how we are addressing it. I will not get into details about what we are doing, just give you an overview. Will that be okay, Rahul?
Yeah, perfect. Thank you, Shekhar.
All right. So name of my company, HyZero, and it comes from hydrogen zero emissions. So right from the beginning, we focused on creating products that use hydrogen as a fuel, and the output is zero emissions. And as most of you probably know, the output of a hydrogen fuel cell is water vapor and spent air. So that's where the original name. We are based in California, but we have an Indian subsidiary and we have Taiwanese operations where we are doing our application research. But the intent is to make this in India, export globally, and do it using Indian talent, Indian knowledge, and make mistakes here so we learn what is, and we then own this technology we meaning India owns the technology because it's been developed here and done here. That's kind of overall focus of, let's say, strategic focus of why we are doing this. And then the second part, which is on the slide here, which says basically we want to appeal to the bottom of the pyramid, meaning, and this term, by the way, came from an Indian professor, 𝗟𝗶𝗏𝗏𝗏, who's teaching at University of Michigan, where he came up with this whole bottom of the pyramid concept, looking at Nirma washing powder. And his point was, if you can satisfy a very price-sensitive group of people, then you can make your product, sell it anywhere in the world. So we are kind of taking that to heart, and we want to bring the benefit of hydrogen fuel cell to the people at the lower end of the economic spectrum. So the volumes are large, selfishly, but also benefit is to them, improves their lifestyle. And then lastly, the point is that I founded this company with my co-founder, who is Taiwanese, and that's why we have some operations in Taiwan. Yamini, if you could go to the next slide. Thanks. Not going to go through in detail because I think Yamini already covered some of this, but just to make a point, hydrogen is what started the universe. Hydrogen will be probably one of the last elements of fuel left in the universe. We expect to run out of sunlight in about 5 billion years. So for all practical purpose, unless somebody has plans to live to 5 billion years, we're going to have infinite supply of the fuel. Right? And like I mentioned, if you use it in a fuel cell, your basic output is just water. So zero footprint in consumption. There is a footprint in production, and we'll address that a little bit later. It can be transported in large volumes, which means you can export it, you can build it, but there is a process involved in making it transportable from a gas form when you make it. We talked about energy density already. I'm going to skip over that. And we have, we basically are focused here to make large number of applications for large volume users to use large volume of hydrogen. Right. Next, please. All right. So here's where we see the market. I think Rahul mentioned this before, that a lot of activity is going on in the larger vehicles, trucks, buses, locomotives, cars, right? Aggressive development, products already in the market. There is very little activity, and I'm so happy to see Siddharth is working in this field because we can learn from each other. So in the small size, very little activity. But I see this as the real volume market. Just to give you a number, there are 20 million scooters, two-wheelers sold in India, 1 million auto rickshaws sold in India every year, compared to cars, buses, etc. when you start looking at the numbers in the market. So that's where we feel the opportunity is in terms of volume. It also gives the biggest benefit because with volume, you get economies of scale and so on. We also feel that fleet sales, at least at the launch stage, would be more useful because individual sales will require a very large sales overhead, whereas fleet sales, once you convince a person and they find it really works, repeat business is much easier, right? We also want to address the issue of failure on cars. So the first point in my slide talks about large applications. And I think all those are viable, but the cars have not been successful. I actually own a Toyota Mirai, and I have struggled finding fuel distribution centers. So the cars, just to give you a number, it costs about $250,000 for Toyota to make one Mirai. They sell it for $80,000. So they're losing money every time they sell it. And that's not a sustainable business. So if you're a sustainable economy, then we need to have sustainable business also. Next, please, Yamini. Okay. So some of this, again, Rahul and Yamini, you covered. I'm going to do that, look at these from my point of view or our point of view as a company. There is no hydrogen refueling infrastructure right now. So if you are selling a hydrogen-powered equipment, whether it is stationary or mobility, you have to make fuel available, and it is not available. And a lot of people will have unique applications, unique delivery systems. We are one of them. So we will require also unique infrastructure as well. Now, the problem, I mentioned 𝗘𝘅𝗽𝗵𝗁, the reason it has not worked well is because you have no fuel infrastructure. And the reason you don't have it is because, at least in California, it costs $3 million to set up one point of sale distribution. So we have to address the cost of equipment for delivery of hydrogen, in addition to cost of hydrogen to make it and distribute it, right? Which brings you to my second point, the cost point. So if you are pressurizing hydrogen or liquefying it for distribution and storage, and then retail, there's a lot of costs involved with not just doing the physical activities of pressurization and liquefaction, but also your entire equipment depends on, or rather has to be compatible with high pressure, low temperatures, and things like that, which again increases your cost. And the reason you have to do it is because hydrogen is explosive gas. So you need to address the safety issues if you're ever going to have a successful product, right? And the other problem I see with hydrogen costs is that there are all kinds of projections, but nobody can stick to it. And in fact, Siddharth caught me on that issue in Davos, where he says, well, if you can make it cheap, I'll buy 100 tons from you. So my goal today is also walk away with a PO from Siddharth, because that'll help me. Okay. So, but cost is an issue for the entire industry. Siddharth and I and people like us will have to address it before we can sell even our first unit to the consumer, right? So test is okay, but if you're selling the units, you need to have good infrastructure. Then for light hydrogen utility vehicles, you just do not have any regulations. So when they issued guidelines for hydrogen cars, bus, trucks, etc., they did not even mention two-wheelers and three-wheelers, which is the largest mobility section in India by numbers, or also probably by travelers as well. So a lot of regulatory work will have to be done, starting with people like Siddharth and I, letting people know that we exist, we have a viable product, we are doing something. And all this we'll have to do together as a small hydrogen vehicle consortium or something like that. And a lot of you in the audience probably are in the situation where you can influence or guide the regulations. So please keep in mind, small vehicles are the large opportunity, especially for a country like India. We have a viable option, Siddharth and I. So we will require all kinds of support to get the approvals for these things, and a lot of advice, guidance, etc. And that brings me to the last point. If you noticed, I mentioned Siddharth several times in the conversation, and I haven't really talked a lot with him. I've just looked at his website more than anything else. And I believe that collaboration is critical for this segment to grow and grow rapidly. Some competition will always be there, but the whole thing that I'm going to kill the competition, the risk is you'll kill your own brother in the process. So we need to be very cognizant of the fact that we have to work together in this while protecting our own interests and our old strategy, and perhaps even modifying our strategy to collaborate better. Yamini, next slide, please. Okay. So this is one example of what we need to tackle. Range is always going to be an issue for our consumers, right? Because there's a range anxiety, and depending on application, you need to have adequate amount of fuel on board. If you're using pressurized cartridges, then the weight of the cartridges itself will be very high. So you need to consider all this things, such as how long does it take to recharge? Can you swap the cartridges? We call our fuel delivery system a cartridge system. You just replace one with another. It takes us literally 1 minute to refuel an auto rickshaw. So But the refueling time, we have to compete not just with battery, which takes 8 hours sometimes, but also with CNG, which takes about 5 minutes. So we need to be equal or less than that. And then your total cost of operation needs to be less than the current system, which is mostly CNG, some IC engines that are petrol or diesel based, but mostly CNG. And then we need to be on cost similar to the battery electrical vehicles, and there are already on the market. For example, Mahindra makes a really good product. So that will be another example. And towards that, what we have done is we have created our system, which is basically take the battery out, put our system in, integrate this electronics, and you have a viable product on the road in very short time. Yamini, next slide, please. Okay, so I'll go through this really fast. As I promised, I'm not going to talk a lot about my company right now. I'm going to basically leave that for Q&A session so that if there is interest, I can talk more. If there isn't, we don't waste everybody's time. But our approach basically is to focus on practical, large volume applications. So we're not going to go for niche products. So somebody says, can you give me 50 drones? Not right now. Once we have mass production of these things, we can fit them in. But right now, we're looking for applications like that. And these applications include three-wheelers, two-wheelers, golf carts, things like that, right? The second part is that we recognize, and as I mentioned earlier, that you cannot just sell a fuel cell system. By the way, our focus is not on making vehicles. Our focus is on making fuel cell systems that fit into vehicles. So the idea is to create an ecosystem that will support this thing. You can't just launch a product. You have to have fuel available, you have to have distribution, you have to have manufacturing. So the entire upstream ecosystem, as well as the entire downstream ecosystem, which would be how do you repair it, how do you replace it, how do you recycle it, all those things need to be addressed. And then our approach to this is that we will make fuel cell systems. We will not make vehicles that will fit into vehicles. So basically, OEMs, vehicle manufacturers are our customers. We are not competing with them. Okay, and the systems that we have developed, which took roughly 20 years. Original patents are from University of Utah, developed in Taiwan, and now we're bringing it to India. So we want to do a system that is compact, is low cost, is high quality, is durable. And the focus always is going to be on cost and safety, right? And towards that, we have developed a fuel delivery system which does not use pressurized or liquefied hydrogen. We use metal hydride to store the hydrogen and release this hydrogen. And this is done at atmospheric pressure plus a few notches above that. But against, let's say, 10,000 PSI, we are 150 PSI. And our concept is to deliver this in refillable cartridges, which last 30 years, lose 3% capacity. And we want to do this refueling and swapping versus having people wait for that. Actual refueling of a system takes or cartridge takes about 2 hours. Okay. The third element of what we're trying to do as part of ecosystem is we want to go first to villages and small towns. And for that, making hydrogen locally is much more economical than making it centrally and trucking it, because then the compression and liquefaction comes into picture. So we have a system for that. As I said, I won't talk too much about my company. I'm going to just keep moving. Yamini, next slide, please. Okay, so what we have is a refilling station that will recharge these cartridges. And that station is where the rickshaws or two-wheelers or whatever vehicles will drive up, deposit their old spent cartridges and take away the new ones. And this increases safety, speed. One station can support an entire town. And our target for pricing for this, and apologies for using dollar figures, but I think in dollars, so it's easier for me. So it's $20,000 US for installing the system. as compared to 3 million in US for liquefied hydrogen storage and dispensing. Okay, next slide, please. Yamini?
I think we are done with the slides.
Yeah, okay, all right. Good. So if there are any questions, I'll cover everything. Rahul, hopefully I covered everything you wanted to cover. And again, thanks for the opportunity.
No, thank you. Thank you very much, Shekhar. I think though your discussion was brief, but the kind of work that you and your team has taken up and the progress you have made is substantial. So definitely quite good things. Could you add a little bit? Like I think you threw a point that it takes almost 2 hours to kind of recharge this metal hydride cylinder. So could you just talk a little bit about this charging technology and how much and what's the current kind of a thought to provide hydrogen supply to it? Like, are you trying to integrate with a on-site hydrogen generator, maybe green hydrogen generator, or you don't care, any kind of hydrogen just gets supplied? So just a little bit of thought so that because that's a very important part of the innovation that HyZero brings, Shekhar.
Yeah, Yamini, could you put up the last slide?
Sure.
Thank you very much. So I'd like to draw your attention to the middle of the page, which is like a little cartridge there. I'm assuming, thank you. So this is roughly 4.5 kilograms. And it has a powdered form of material, which is patented, which absorbs hydrogen when you recharge it. And I'll talk a little bit about how that happens in a second. And you then discharge it on demand as you require it. So for a typical auto rickshaw, which we want to give somewhere between 100 120 kilometer range, we use 6 of these cartridges. And each of the cartridge holds 45 grams of hydrogen. Okay, so that's the core technology. Now, if you look at the left of the slide, you have charging station. So the idea is that you will just push the cartridge with the pointy end facing inwards, twist the handle so it locks in, and then the system inside has multiple sensors, multiple phases, but at the basic level, what it does is it supplies hydrogen at relatively low pressure. Again, it's not a high pressure system. And it also cools your cartridges as you refill them, because when you fill them, they heat up. So you want to heat them up very little, and you want to make sure that the material inside, which is basically a powder, think about sand, is something like a consistency of a sand. So if you fill it too fast, it'll get overheated and fuse, reducing the capacity. But if you do it in our storage system, using our coolants and so on, then you end up with something that in 2 hours can be refilled without appreciable loss of capacity. There's always going to be some capacity loss, but our tests have shown that over a 30-year period, we lose only 3% capacity if we use our filling system. So it's critical that your capacity doesn't go down. So that's why you require this kind of system. And our concept is that you don't have your own cartridges, you just repeat and take the new ones out. So we control the integrity of the system, we control how many cycles has been recharged, we can test it in cycle, etc. So we retain that know-how and then keep on getting better as we learn what works, what doesn't work. So risk of this is on our side, not on the consumer side.
Wonderful. No, I think that's a great, Shekhar. And this typically a smaller unit of it will be supported by what, 100 kgs of hydrogen for 200 auto rickshaws to move in a day?
Right. So we anticipate each auto rickshaw that runs about 150 kilometers to require half a kilogram of hydrogen a day. So for someone who's trying to sell hydrogen, you can imagine what the market potential is for sale of hydrogen just to auto rickshaws alone.
Mhm.
So it's half a kilogram a day. Each unit can support roughly about 100 auto rickshaws
Okay,
with one filling station.
got you.
But that's flexible because this is a modular system. So you can double, triple, quadruple the capacity. Just keep on adding units. So think about a petrol station that has one pump, and now the demand goes up, you add another pump, but you use the same road, same tank underneath, etc. Somewhat similar to that.
Wonderful. So that is great, Shekhar. I think it's a fairly modular designed architecture. I think good point. Thank you. Let me bring Siddharth now. Siddharth is another dear colleague working from Pune, H2e Power. And in addition to working on three-wheeler application powered by hydrogen fuel cell, Siddharth is also looking into tackling the broader hydrogen ecosystem. Maybe he will tell more, but he also is doing electrolyzer and also deploying electrolyzer for some of the clients as we are speaking. So with that, Siddharth, I know you have not put up a PowerPoint presentation. So if you can take us through your journey at H2e Power, right? Especially with a focus on your three-wheeler application that you are developing. What use case, what's the configuration and architecture for this vehicle, as well as the charging refueling ecosystem for hydrogen that you have envisaged? And how are you comparing this vehicle with something that is existing in terms of battery as an option? So that will be great to understand from you, Siddharth. Over to you.
Thank you, Rahul. Thank you, Yamini, and welcome everyone. I think we can still say Happy New Year because we're still in the month of January. And the year has been really, really exciting for us. One of the exciting things that happened was in Davos, and signing up with the state government was, of course, the exciting part. But meeting new partners, and I always say partners because, as Shekharji rightly put it, the industry is at such a stage that we cannot be competitors. We are collaborators and at best co-opters, as I call them. You could be competing at some point 10 years from now. But right now, it is the time to put together our heads in terms of technology, business model, on the policy framework with the government, and make sure that we are able to bring value to the end customer. And I think that's the most important thing. And that's one of the only reasons why we are in business, is to find the pain point and see how we can replace that. Green, of course, is an important area. We are all big believers of green technology. We are all very passionate about climate. We are very concerned about climate. But the man on the street, especially if you're talking a two-wheeler and a three-wheeler driver or owner, they may be concerned about the environment, but that necessarily is not the only thing on their agenda, because most of the people are struggling to find the second bread for the day or the next meal for the children. So thinking about 2040, 2050, whether the world will survive or no, their world is going to collapse tomorrow morning. So, for them to think that environment is important and they would pay extra money for the environment doesn't happen. And therefore, the responsibility comes on people like us and Shekharji and all people working in technology to see how we can bring green technology at a cost parity, at a level where a person on the ground can afford. And the topic that we've taken today, and what Shekharji is so passionately working, and we at H2e are also working on, is to bring high technology, bring sustainable technology to the three-wheeler and the two-wheelers. Now, these are again, the ticket size is anywhere between 50,000 Indian rupees up to 350,000 Indian rupees between the two-wheeler and the three-wheeler. If you go 351,000 rupees, then you lose the sale. 1,000 rupees can lose you the sale. So while working on this, see, we as a company, we've been involved with a lot of different things in the entire value chain of the hydrogen or the net zero ecosystem, I call it, which is production of electrolyzers, production of fuel cell, also production of hydrogen, ammonia, methanol, SAFs. We are in the upstream and the downstream activities. And in the midstream, we are working a lot on the stationary side, and we've started working on mobility for the last 3 years, where we also built a bus which is now running on hydrogen in the region of Assam. The three-wheeler, when I started working on this concept, a lot of people, including my own team members, said that it was an unviable idea, because just the cost of a 5 kilowatt or a 6 kilowatt fuel cell would be about 10 lakh or 12 lakh rupees at best. So how are we going to make the auto rickshaw affordable? So the first decision that we took was that let us not get into the passenger side, let's get into the good side of the three-wheeler segment. And technology-wise, I think Kshekhar has covered it, and that's very similar to what we are trying to do as well, because heavy investment in the refueling infrastructure, the high-pressure tanks, they're not only expensive, but they also carry a safety risk. When you're talking about such a mass scaling of things, safety becomes a very, very important element. And I would not say that we are careless in India about safety, but that is something that does not come naturally to us. So if you go to California, where HyZero is based out of, or if you go to Germany or any European country, the safety parameter would be looked at least 10 times. Even a person going in to refill a vehicle, forget about hydrogen. I've seen people in Germany filling a diesel vehicle, and they are so careful. They will make sure they switch off their mobile phone before they enter the gas station. They will make sure that all utilities in the car are switched off. So those are things that they already take care of. In India, we take a lot of things for granted. I always joke with my friends in Europe that we have 330 million gods, so there is a lot of things we can take for granted. So therefore, working on something which we call as foolproof or idiot-proof in that sense is something that is very important. And that's where this refuelable cylinders and cylinders that can be replaceable, just like you swap the battery, you swap the cylinders. That technology is something that is very important, not only for the two-wheeler and three-wheeler segment. I'm also working on that on the stationary side, so just to make life a little easier. And that also reduces the cost of compressing, which in the hydrogen terms, whoever knows hydrogen, is a big cost. Compressors are the notorious part of the whole puzzle right now. So therefore, it makes a lot of sense. Now, where we come from is that if it is a public utility vehicle, whether it is a bus, it is a three-wheeler, or it is a train, all of these need to have larger asset utilization. You cannot keep the asset idle. If I'm charging the vehicle for 3 hours or 4 hours, like a typical three-wheeler in Pune city, they go with a range of about 80 kilometers or 90 kilometers, even 100, 110 kilometers per charge. In a city like Pune, they finish that charge by about 3 o'clock in the afternoon. And that's the clock you are left with zero business. So we thought that how can we increase that business? And that's where this whole idea of hydrogen-powered vehicle or hydrogen-powered hybrid vehicle for the three-wheelers came into being. And with the 210, 220 kilometer range, we can easily last up to about 8 or 9 in the evening if the gentleman starts at 6 in the morning. And if they're still left with power, this vehicle can charge their homes when they reach home. So this actually, it's a power plant. Just imagine that you have 20,000 auto rickshaws with a 3 kilowatt or a 4 kilowatt fuel cell on board. So you're talking about almost 60,000 kilowatt-hour available. That's the power available. So there was just a wild idea I got once, that what if the grid needs a lot of power? It can just ping these three-wheelers and bring them to charge the grid. So that's those are fringe things that can go with it, but it actually becomes a third earning member of the family if you're really looking at the three-wheeler side. On the two-wheeler, of course, when I met with Shekhar-ji's colleagues on train, this was very interesting. We were traveling from Zurich to Davos, and that's where I met them, and we started talking about what they were doing in the cylinder space and the fuel cell and the two-wheeler. And the first thing that came to my mind was an advertisement that I think Bajaj Auto or Hero had: fill it and forget it. So that literally is what can happen when you do a hydrogen-based two-wheeler. The guys will get tired of it. They will not need to refill the vehicle for almost 20, 30 days, or maybe more, depending on how they really use it. And these technologies, again, are very safe. I think one thing that I want to bring out here, whenever I speak to people, when they talk about hydrogen, they always remember that one incident that had happened, or one video that everyone sees of a blast on hydrogen. Of course, hydrogen is very, very lethal, but because it is so dangerous, we technologists, whenever we work on anything, these cylinder cartridge that you saw on the slide Shekhar-ji had presented, these have gone through several safety checks. These have gone through so many safety tests that they are much more safer than even the gas cylinder in your house. They are much more safer than the lithium battery sitting in your car, which you're driving as an EV. So unless you tamper with with it, unless you play around with hydrogen, it is a very docile and a very nice character. You play around with it, it becomes a very nasty animal. So those things, I think, they're always to be taken care of. And what we as a company are also doing is we have an entire a vertical on skill development, and also on customer education. So we're not only developing trainers, we are not only developing people to fit these equipments, or do the swappings or whatever, but we are also having modules where you train the customer on the do's and don'ts. We have programs on skilling, upskilling, reskilling, so that all of us will get appraised with what we are getting into. See, we are going through a radical change. This is a change that is happening for the seventh time in the history of human civilization. When we are changing the fuel, we've only changed fuel 6 times so far since human beings inhabited Earth. So it's a very historic thing that is happening. And when there is a change happening, there is also excitement, and there is also resentment. People are very scared about change. So it is a duty for people like us, entrepreneurs like Shekhar-ji and myself, to make sure that the transition becomes easy. We do not get into the face and say that, hey, look, this is some high technology we've got from Europe or from the United States or Canada, and this is the next holy grail, but it's going to take you a lifetime to just understand how to use it. So it has to be simple to use. It has to be simple to replace. And that is the principle that we have followed. And that's the principle that I saw in the slides that was presented as well. One point that I want to bring out, and I was talking to Rahul also the other day on the entire three-wheeler and two-wheeler, the light mobility segment. Now, for me, I work on different segments of mobility. I'm also working in shipping, for example. So we are developing a complete fuel cell system which will run on ammonia as a fuel, and then power a complete liner which is going in the deep seas. So working there, we've done the bus, we're doing the three-wheelers. Very excited to see the two-wheeler, though we don't intend to get into that segment, but excited to see how that works. But I think on a policy level, and this is something I spoke with the Honorable Chief Minister as well when I had a brief few minutes with him in Davos, is that the government always becomes the largest uh, uh, catalyst to doing these things. And then he asked me, what is the kind of subsidy you guys need? I said, sir, that is a bad word for me. I need zero subsidies, but I need the government to bring more demand for me. So maybe we could identify, let's say you identify Pune as a region, you identify Nagpur as a region, or identify Aurangabad, or within Mumbai, just identify South Mumbai as a region, just like we're doing the Hydrogen Valley. Let us do a complete region where the government spends and let's say does 5,000 three-wheelers or does 10,000 two-wheelers, say for a particular department in the government, let's say the Greater Mumbai Police Force. The whole police force can only go on hydrogen two-wheelers or on hydrogen three-wheelers, and the government can pay for that. And if the government is doing an initiative like this, you could get funds from a World Bank, or there could be a lot of other impact funds that could come. And once that is done, that ensures that there is acceptability of the technology, that ensures there is critical mass, which helps us reduce the cost, because you always get those volumetric efficiencies. So in terms of policy, I think that this is something that I always keep talking to people either in Delhi or even in Mumbai, that give us more business. Don't give us any subsidies. Subsidies are bad for the business. But if you give us more business or give us opportunities, that look at this sector and do it, and give us a cost target that for the first 100 two-wheelers, this is the cost target. Next 100 is this. The third 100 is this. And I'm sure technologists, and we are just two of us, like Shekhar-ji said, I was also very pleasantly surprised that there is somebody in India doing crazy things as what I'm doing. It was very nice to know.
Shekhar, I have a question on your cost target. What's the cost target for 1,000 three-wheeler loader application you will take up?
No, I put it the other way around. It is 3.5 lakh rupees. You go and ask owner of a loader three-wheeler how much he can afford, and we did a survey. Nobody gave me a number above 3,75,000. So that has to be the cost target. If we don't meet that cost target, we don't have a business.
Got it. And you also want to go with the architecture of swapping the cartridges, like what Shekhar is
We
doing?
are doing 380 gram cartridges. We're doing a little larger because in the three-wheeler you need a larger number. So we are trying to achieve 1.2 kilograms. So we would have 380 times 3. So it's coming somewhere close to 1.1, 1.2.
And what's the technology like HyZero is using metal hydride? How are you kind of
It is something very similar to metal hydride. It's on the same chemistry. This is something we've developed here in India. And we, of course, struggled with finding the right materials, but fortunately we have. And we are moving now from the SS tanks to the aluminum tanks. So we'll make it much more lighter and much more, easy to pick up and put. We've also developed some connections where, you could see, we are talking about hydrogen, and leakages can be very damaging. So when you swap a cylinder, we have to make sure that the fitting is so good that it will snap up in less than 3 minutes. That's again one target. And there can be no leakages, because when you're talking about removing the cylinder and putting it in, and that is going to happen at least 200 times in a year, or maybe 100 times in a year. So you need to make sure that the mechanism is good, and in the 5th year or the 10th year, even then there is zero leakage. So that is something that is work in progress right now, the fittings, because there is a good fitting available from a European company, but that fitting is so expensive that, my whole project can go to hell, even if my fuel cell or cylinders are inexpensive. So we are working on with the government. There is a hackathon that the government has agreed to put to develop these fittings. So see, the government is doing something very interesting, and one thing I would like to speak in favor of the government. Whenever you go to the government, especially on this subject, that's my subject, so I've not gone on any other subject. They are so receptive, and right from the minister up to the principal secretaries or lower bureaucracy, higher bureaucracy, they are all very willing to come up and listen to ideas. So in one of these deliberations that Prahlad Joshi ji had called for, and I mentioned to him that these are the problems we are having. How do you solve that? So he said, what help do you need? I said, sir, we need to produce these components in India. We need to encourage people. So we found out a new idea there while just sitting in that meeting, that why not we call for hackathons? And after calling hackathons, I said, I will bring a couple of more companies who will underwrite at least 1 year of the production that this startup makes once they win the hackathon and they're able to develop a product to this particular spec and quality. We will buy their 1 year production. So, so that is how the ecosystem has to get built. If you just look at a fuel cell or an electrolyzer, there is 390 components. So we are trying to do that for every component. If I can localize every component, then I can bring down the cost to a level where we can sell it to literally every home. And that's the whole idea.
And Siddharth, like in terms of moving to aluminum, what's the weight of each cartridge that you will be having? How much refueling time it will take?
The weight of the cartridge would be less than 12 kgs is what we are targeting. I don't know what number actually comes out for the 380 grams, and the refueling time will be longer. And so I really don't care about the refueling time because we are going to get one of those good-looking charging ports that Shekhar-ji's company is making, and get them there. So it really doesn't matter whether it takes 1 hour, 2 hour, 3 hour, because what we'll do is, and what my idea was that let's have a centralized hydrogen production plant. Like in Pune, I'm setting up a production plant to produce 2 tons of hydrogen per day. So there we will refill 1,000 of these tanks, and then they'll be available all over the city. So wherever you need it, we have technologies, we have IoTs of the world, or AIMLs, where we can use to the point systems which can guide the driver to a point where he or she can get this replaced cylinder.
And you want to share anything about your fuel cell? Like I'm seeing a lot of questions from the audiences already asking like what kind of technology is in fuel cells, what can be the trends that we can expect to kind of reduce the cost in the fuel cell. So where we stand on the fuel cell part, Siddharth?
I wish I had a crystal ball to give answers to that, but you'll see. It is the PMFC fuel cells which are more suitable. Of course, my company, we do solid oxide as well as PEM fuel cells, but the PEM fuel cells are more suited for this. And in terms of cost, we are still a little distance from the expected cost. So, I'm expecting the cost to come to a level of $220, $230. And again, this $230 was a number I had thought when the dollar was 70. I don't know if the dollar may be 100 tomorrow, but that's the number, with $230 with $70 to a rupee price point. That's where we are trying to look at. Platinum remains one of the key issues with the PEM fuel cells, but there are a lot of technological developments happening across the world, and it's very interesting that we currently are working with 6 companies. All of those 6 technically are my competitors. We are sharing IP, we are sharing knowledge, and we are trying to see how we can bring down the cost.
Wonderful.
So each one of them, if you go to them and if you look at me, you'll say that you guys are absolute competitors with each other. But there is a lot of active sharing happening, and we all realize that if we go after each other's blood, what Shekhar-ji also mentioned, the industry will not remain. We definitely will remain without business, but the industry will disappear. So we really need to work together to make sure that we deliver a product which the customer can believe in, and therefore the industry will grow. And once it grows, there is so much business that you need at least 100 of H2Es only in Pune city to cater to the demand that is going to come.
Wonderful, wonderful. I think with this, let me bring Shekhar again. Shekhar, like what is the use case, let's say in two-wheelers, that you look will really be appealing and economic wise also attractive for first scalable demand for HyZero in two-wheeler space, Shekhar?
Okay. So let me divide two-wheeler space into 2 groups: consumer use and commercial use.
Yeah.
Okay. If you remember, my focus in my talk was more about reducing costs, making it available to everyone, right? Here's the problem with two-wheeler for personal use, right? typically a scooter will require 10 to 20 grams of hydrogen per day max. And as Siddharth correctly said, you put in a cartridge, you don't need to change the fuel for a whole month, right? So you have to go think about your people who are supplying you with hydrogen, right? So how much money is a retailer going to make? How much money is the distributor going to make? How much money is the producer going to charge you to provide you with hydrogen, right? So if you have a two-wheeler, imagine two-wheeler you live in Nagpur, Rahul. So let's just imagine Nagpur, right? So roughly speaking, Nagpur is a city of a radius of maybe 10 kilometers, the core of Nagpur, right?
Yeah.
To provide two-wheelers, you have, I'm still talking about personal use, right? Individual use. First of all, your salesperson has to sell to one person at a time. And let's say your product is fantastic, which Siddharth and I both will assure we have fantastic product, right? So a product is fantastic. It lasts 5 to 10 years. I've convinced a guy to buy the vehicle, not me, my salespeople on the floor have convinced people, right? This guy's gone for 5 years, 10 years because he's happy with the product. And other than some word of mouth, I do not have a repeat business from this one customer, right? And even when the customer comes back 5 years from now, I have to re-educate the customer because things have changed. So now if I move, so if you move on the cost spectrum, my sales costs are high, my dealership cost, the demo store, showroom costs are high, my sales unit is very low, which means my overhead of selling, equipment, etc., is also high. Plus, if I'm selling to individuals, I have to have my fueling station distributed all over the city, right? Maybe if you say 10, your 10-mile radius, you need to have at least fueling station within 2 kilometers. Now imagine how many points that creates. But if I have a taxi stand, okay, let me actually, before going to taxi stand, let me say, if I have a fleet sales, Swiggy, Zomato, Amazon, etc., they all come to one point to pick up the material and go out. One unit can support their entire fleet. So my equipment cost per gram is much lower versus retail sales. So that's how I separate those two things. Did I answer your question?
Yeah. So I think it makes sense, like hydrogen for its kind of range and other benefits that it provides, plus the economics per unit, be per gram of hydrogen supplied or equipments. I think long range, long distance per day use kind of a commercial segments, I think would make a lot of case for this. Have you got a chance of comparing, Shekhar, a two-wheeler electric for a commercial use versus a two-wheeler hydrogen power unit for a Zomato? Like how will they make a business case to choose between one over the other? Because they all have made a commitment as part of our partners' work. Many of these companies have taken a commitment for 100% transition by 2030 and some years. So that's a very good point. And because we work with a lot of the CXOs in helping them with their transition, especially at fleet level commitments, this is a broad question, like how do we shift across technologies? So what are your thoughts between battery electric two-wheeler versus your solution for a fleet company doing, let's say, 150 kilometers a day?
So I'm going to refer to something what Siddharth mentioned also. And in fact, if with your permission, Rahul, I'd like Siddharth to speak to the reason why they are not focusing on two-wheelers, because we might have gone along the same path for same conclusion, but especially if Siddharth had a different path to the same conclusion, I would love to hear that as well. But now answering your question, Rahul, we have compared two battery with hydrogen, okay? We are not focused on making or selling two-wheelers. If an OEM in your audience comes to us and says, could you do two-wheeler for us? We have the technical capability. We have developed two-wheelers. In fact, we first started with two-wheelers. What we found out was that it doesn't make business sense to launch with a two-wheeler. So what makes sense is high use of hydrogen, fleet sales, taxi service. Then when the hydrogen is available in a city, small town, then you start expanding that footprint by opening more distribution centers, and then the two-wheelers will come later. But even there, most likely scenario is the fleet sales first, then individual sales. So in the timeline, and we didn't talk about timelines earlier, our goal is to launch full automated production from Nagpur in 2028. And which means that we'll be actually producing and shipping product in 2027. And for those in your audience that are interested in working with us, we are ready to sign a PO now for proof of concept and pilot projects. In other words, we have product now. So it's not a aspiration. It is not hoping it'll happen. We actually can ship product now. But coming back to, again, the question of how this rollout will happen, fleet sales where there's high volume, then two-wheeler fleet sales, then individual sales.
Sure. Siddharth, if I may bring you in, the question that I'm trying to ask, typically when you compare in engineering terms, the efficiency, if I just say tank to wheel efficiency, between a pure electric versus a hydrogen fuel cell driven vehicle, then in battery electric, we are talking of 80 to 85% tank to wheel efficiency, right? Between battery, transmission, and at wheel. When you are bringing the hydrogen fuel cell, then with the fuel cell, and then followed by battery, transmission, and this thing with the fuel cell efficiency around 50%, this efficiency starts coming around at 40%. So that's only one metric, right? On engineering terms to compare between a battery electric versus hydrogen. How does your loader application sells in to a cargo fleet user? What are the economics that make sense for hydrogen versus battery electric in three-wheeler cargo application? Whatever is your ideal user base that you are seeing, Siddharth?
Rahul, one point I want to make is in terms of the percentages, this efficiency percentage numbers sometimes can be misleading because, it's always, a lot of people also always ask me that you're going to spend a lot of water to produce hydrogen. So where is this water going to come from? And I always go back and ask them that, do you even know how much water is consumed in the refinery to extract crude and from crude to here? So because that water is not spoken about, we do not know about it. So similarly, in this, again, EV and fuel cell are not competitors. So battery is not my enemy and vice versa. The three-wheeler or any vehicle we are talking, we always say it is FCEV. So it is a fuel cell electric vehicle. So the drive remains the same. It is the electric drive. We always
the source that you are changing.
Yeah, we are essentially doing is that we are reducing the dependence on the battery and we are putting a power plant on board. So there is a power plant on board which is also charging the battery. There is a smaller battery as compared to the normal battery that would come. So battery is always there. It's not going to go away. We are not replacing the battery. That's number one. Number two, coming in terms of the use case. So we are talking to a few fleet owners, and I think as Shekhar-ji also mentioned, that is the immediate the mid-hanging fruit. They're still not a low-hanging fruit, but they are at least achievable in that sense. So for them, setting up their own power plant to produce hydrogen. See, most of them are also investing into renewables. So just take Ola as an example. I mean, I'm just off the cuff, just taking any name. But with Ola, if they have, or say Flipkart, I mean, or Amazon could be a better example here. So Amazon has 100 delivery vehicles in the East Pune region. So for that East Pune region, they have a hub. So on that hub, it is very easy for them to set up a small hydrogen production plant. And the plant can be set up in a 40-feet container, which can produce up to 150 kilograms of hydrogen per day and with a standard storage and where they can refuel these tanks. So they are controlling their energy story, their energy destiny, which I think is a greater kick for them. The cost, of course, is but that is something that they were very receptive to when we spoke to them. In terms of the cost, if you take the total cost of ownership or the levelized cost, if I consider the downtime cost of charging the vehicle, if I take the downtime cost of the battery getting charged for 3 hours, 4 hours, and the business that the vehicle could do, if you're taking all of that in consideration with the high capex on the fuel cells today, I am about 10% more expensive.
Okay.
Okay. But if I just do standalone, then maybe I am about 30-40% more expensive. But all of these things you have to consider. And because as a fleet owner, you end up paying for every second, for every minute. Okay, so these are going to be, I don't see these as very easy sales. They're going to be tough sales, the initial ones. But once the initial ones work, everything works as a herd mentality, whether it is at the bottom of pyramid, at the top of the pyramid. If one fellow does it successfully, everyone wants to follow that. So, we have to create one success story, and that's all that we are chasing.
Got it. And in your 10 to 40% band, you have given how much hydrogen cost you have assumed per kg today.
See, today I am already selling hydrogen. So now we have contracted for sale of hydrogen. We are selling hydrogen at 400 rupees a kilo, but that is at a very high electrical input cost. Just before I came into this meeting, there is a good news that I got from one of the colleagues in the power ministry, that the TOD charges that MSCDCL was charging for this green hydrogen, they've agreed to do away with that.
Oh,
That
good.
really will help, because that TOD charge was, it was making things very difficult. We had made representations to the government on that. So we are trying to see if we can bring that cost of electricity in the 2 rupees 20 paisa, 2 rupee 50 paisa round the clock range. Right now it is available at 2 rupees, but it is not round the clock. We need round the clock power for hydrogen. So if that will come, I think we'll be able to sell hydrogen in the range of 230 to 240 rupees. That will further change things. So, as all of these things are working in parallel, there are too many things happening right now with the policy level, with the cost of solar, the ALLM policy of the MNRE for localized solar production. How will that impact? So ultimately, when Mukesh Bhai mentioned 111 in that famous speech that he made, that 111 was considering that cost of electricity will be 90 paisa around the clock. So that's where we have to reach. If we reach 90 paisa, goodbye to all fossils, their history.
Wonderful, wonderful. Let me bring Yamini. I think I'm seeing a lot of almost 24 plus questions coming from our 100 plus participants. Yamini, what are some of the adding up questions to already discussions, please?
Right. I think add-up questions are there, but also there's one interesting question from Mr. 𝗟𝗶𝗴𝗵𝘁, where he's saying that metal hydrides are generally costly and suffers from poor life cycle and usually works at high temperatures with low hydrogen storage capability. So I think this is more directed towards Shekhar, that do you think metal hydrides are more economical than on-site hydrogen production? If so, what are the key drivers driving it? I think you are on mute, Shekhar.
Yeah, I just realized that. I'm sorry. So there are two different things, right? Hydrogen production and storage for distribution and retail is one thing, and hydrogen on board for a mobility application is another thing. So I will answer the question, but I'll divide it into two parts. And I'll start by saying I have no idea about the distribution retail, the system that Mr. Pandey is talking about, because not my expertise. I will focus more on our system. Our data, our results show that if we use our refilling system, which does have refrigeration almost to 0 degrees, right? So it's a very cold system. And if we use that, we get 3% loss over 30 years, right? So our results are not that. Now, I'm sure there are literally thousands of potential metal hydrides available. So we came with You think about kind of a multi-axis kind of coordination. We have found a middle space where the cost, the recharge cycle, the life of the thing, etc., all kind of comes in. We have found one, right, which we are using. I am sure we'll find another one and another one. Siddharth might find one, and we'll collaborate and we'll license their technology, or vice versa, right? So I kind of wanted to address this as separate things. Our technology gives us a very long life on the system, provided you stay within the system. If you try to fill it like somebody does jugaad, saying, let's connect high pressure hydrogen to this cartridge, not only will it not charge, but it'll basically damage it. And you talked about heat, very good point. Reason we need to refrigerate is because we don't want heating. Reason we don't want heating is because if it gets hot, our sands like powder gets jammed together and surface area gets reduced, so the capacity drops. Final point, we are 10% less efficient in storage by grams per kg of the equipment. So our unit is 4.5 kilogram, we hold 45 grams, so 1%, right? If you were to use the same size cartridge and just put compressed hydrogen, it will be 10% more. It'll be 50 grams, plus minus. We actually store 52 to 53 grams. But the remainder 5 grams is because it's so hard to extract that last 5 grams that we generally don't bother, because the cost of extracting, the time, the efficiency drops, so we don't do that. So we just say 45 grams.
I think this is a little generic. Maybe this question either of you can take. Could biomethane be an input into HyZero? Maybe actually it's pointed to Shekhar, you. Could biomethane be an input into HyZero production unit of distributed hydrogen? And if yes, do you see that it can bring the production cost down significantly? So I know you are working on some parts into it, Shekhar. So if you can answer this question and give us some efforts that you are putting and what cost you expect hydrogen to come from the bio waste productions.
So I am, first of all, yes, easy answer, right? Yes, but it has a lot of nuance to it. Our chief research officer has developed a project which uses biomethane to make hydrogen from that. The process is same as what Siddharth has. So we might even come to him to buy his electrolyzers, right? Because you need to have electrolysis to split that. But we don't need to do necessarily electrolysis. We could do multiple different ways of splitting steam formulation, et cetera, et cetera. So our approach is slightly different, but before I get into our approach, I need one more minute to explain what we actually are doing. I was focused on meeting the charter of your presentation with slight, give a little bit of idea of who we are, what we're doing. Our project actually has 4 elements. We only talked about one, which is the core equipment, the filling system, and the cartridges. But we are also working on biohydrogen, and I kind of alluded to that when I said 50 kilograms a day, because we believe that unless you have a distributed hydrogen production, you will not meet the cost targets, because transportation cost compression is just too high. So we have developed 2 different, not one, but 2 different ways of converting waste into fuel. The concept is very similar. You make a gas, you split the gas, you make hydrogen, right? So one is a biomethane using fermentation of the raw material. And the other one is using anaerobic heat, just like cracking in a refinery, to extract hydrogen. So we've developed these, we're working on these products. One is ready for our prototyping. Other one is about 1 year away from that. So our focus is, and Siddharth, you would agree with that, unless you have your hydrogen fuel available at a low cost at the point of use, you don't have a business. So our focus is to create that. So that was the second element. First was technology, second is hydrogen production. Third element is we believe that we have to collaborate and bring everybody together under one roof. And Siddharth actually gave me a great example where he talked about this one valve will basically ruin his entire business plan because it costs so much. So not only I want to bring people into India, but I want to facilitate them setting up their own factory in a hydrogen technology park. We are looking at Nagpur for that. And that way, just in time, co-location, corresponding with them as to what we need over the next 1 day, 2 day, 3 day, reducing obsolescence costs, etc., will lower their cost and therefore our cost. Okay. And then, of course, the side project is to indigenize the whole thing, find domestic materials, to replace what is there. Hopefully working with these people, but if not, then competing with these people. So that's the third part. The fourth part is actually bringing these components in from all over the world so that we can start supplying to India. So that Siddharth says, I need 100 parts. Somebody says, I need 150 parts. Now I can negotiate for 250 and get prices lower versus Siddharth having to individually going to somebody and buying only 100 parts. So that's kind of the four-piece concept with that. But with all this stuff, and Mayur, not Mayur, I'm sorry, Siddharth will disagree with me on this stuff. We have already had one brief conversation. My cost is 100 rupees a kilogram.
What cost, Shekhar? 100 kg per kilogram of what? The hydrogen that you will produce?
Correct, right. With our business model, we have a business model associated with that. Part of the business model is using municipal waste because everybody needs energy, but everybody needs to eat. And once they eat, they leave some energy behind. So we want to collect that energy, ferment it, and make hydrogen out of that.
Sure.
But farm waste, poultry waste, cattle waste, all of this is useful.
Interestingly, Shekharji, we are doing a project. Hopefully, by end of this year, we'll produce hydrogen already. We have access to 150 tons of waste every day in Pune, which my partner, his company, they do some social things here. So they collect that waste. So we're doing a small pilot on that. So hopefully we will be able to do know the costing of where it comes to.
Right. Yeah. Well, we should talk. We have a lot of common things to talk about. So
sure.
Talk beyond that. Yeah, that's right.
And
Yamini, sorry, we didn't mean to hijack your agenda.
No worries. I think everything is something that we're discovering. We are learning with you guys. I think it's really interesting.
I don't want to miss this question, Siddharth. It has come from Vikrant, my partner. He's my boss on when it comes to the vehicle engineering element. So it's a technical question for you, Siddharth. How durable are the fuel cells today in automotive usage? And what working efficiencies can we expect from them? Vikrant himself has worked on fuel cells. Lot of his research and other things has gone earlier at GM and before. So with that background, he's asking like durability of fuel cells in automotive use.
It is comparatively, see, we are talking about the PEM fuel cells, so we are not looking at a life like what we talk about in solid oxide fuel cells. We claim 70,000-80,000 hours. Here we're talking about 20,000 hours at best, or maybe 22,000 hours. But if you look at a vehicle, in a life of a vehicle, we can easily look at 8 or 9 years before we need a change of a stack. And if in terms of durability, these technologies have been proven. Of course, there is a lot of discovery that happens. You know, I have this very famous thing that I do with my team. I always tell them that we are in a discovery channel mode, and every time we tend to find something new because different places, like we did the bus, and technically the bus should have run absolutely perfect. It ran perfectly in Pune. We did, you know, the Honorable Prime Minister inaugurated it in Bangalore. It ran very well. It goes to Jorhat and it doesn't fire up. And, you know, it was a major issue and a major embarrassment. But what we realized is that Jorhat has 88% relative humidity for 365 days a year. Now, when we did all the packaging, you always consider humidity, but you don't consider humidity, which is, you know, 24/7 by 365. So those are things these are learnings. So again, when we are doing something on the three-wheeler also, I don't expect, and I hope that we don't get a smooth ride when we do the first trial run in March or April, because there are some valuable learnings. What works in Europe uh, may not work in India. What works in India works anywhere in the world. It's simple. We can stress test any technology. You put it on ground, and our people are capable of finding the pain points which normally may escape people in the West. So right now, I'm hoping that whatever claims we are making will come on the ground. But if they don't, well, that is the scientific challenge. That is why we have the IITs of the world. We'll work with them. We'll find solutions.
Sure, sure. And any positives, any surprises, Shekhar, when you try to work with the OEMs, pitching them this idea, doing a prototyping with them? What is the OEM's take for this testing and taking it to commercialization? Where do you guys stand in your commercialization route journey?
So as I kind of mentioned, we are ready to sign any contracts. We are very close to signing our first one with a major manufacturer in India. For obvious reasons, I cannot mention names. So we have, just based on this one comment alone, I'd say we've had positive reaction. There is a latent demand for this stuff, actually very, very large demand for this one. And we just won't have capacity. If Siddharth and I pool our resources and we say we're going to make it, we're not going to have enough capacity to meet the demand for the next 5 to 7 years. So that's why I don't look at people as competitors. I look at them as collaborators, because together we'll succeed, right? So very positive reaction. Now, the questions, however, are very similar, most cases. And one of that is just the Indian way of doing things. First question I get asked is, has somebody else done it? Okay, where has this been approved? And I said, my whole existence right now, for the last 7 years, I've been working on the project, and for probably next 7 years, is going to be to bring this nascent, new, fantastic technology to India. So by definition, nobody has done it. Nobody has created any regulation for it. We all have to do that. And this mentality of, has somebody else do it, I want to be follower, is a change of mind. So my bigger issue with OEMs is not that they don't find this attractive, provided I meet my goals. For example, cost goals. And nobody's going to sign a contract without a price on it. And if I'm promising them that I'm going to be competitive with battery, then I better take a PO, competitive battery, and make sure I can beat it without going bankrupt, right? So that part, they get it. Fine. If you deliver on this stuff, if the output is this, if the efficiency is this, we are in. But who has done it? What is it? So those are the tougher questions for me to deal with, especially as a non-Indian, because I don't think like local people,
Sure.
right? I think differently. And what I think is, people should be banging on the door wanting to come in, but there is that resistance. Has somebody else done it? Let somebody else take the risk. I'll be the follower. Followers, they don't make money. Followers, they just have lower margins. So in this, I want to support Siddharth's effort too, because I know he has faced exactly the same issues.
No, I think
on a lighter note, actually, I would tell you that this is a situation I had with a government company. I went to them. It's a large public sector company. They told me that, who has done this before? I said, nobody. I'm the first madman that you've met. Let's talk. So, okay. So, cut the long story short, they published a tender. And in the tender, then they had a condition saying that you have 5 years prior experience on this technology. I said, geez, you asked me a question saying that who has done this before, and now you say that find somebody doing that. So it's these are ironical things. These are parts of the legacy public procurement mechanism, and we've been trying to tell the government that for newer technologies you need to change the old aged public procurement systems, because unless you want to fire up things and then get products from China or Taiwan or wherever, if Make in India really is a story, then you really need to make sure that the tenders are conducive enough for startups or people like us to participate and win. So though it's just off the track, but these are things that do happen, and I'm sure a lot of people in the audience may be agreeing with me, because a lot of us face these issues.
There might be culprits that we got to change their mind.
They will slowly. I think India is changing. We are really going in. Like I said earlier, we have a government which is listening and understanding, which is, I think,
That's a very positive, big
that's the
positive.
biggest win for us as entrepreneurs. So it's up to us to do things now. And I keep telling my team, and I know I want to leave this message to everyone here also in the audience, that God and government have too many things to do. So, we need to work for ourselves and try and do things and not rely on God and government.
So let's say if PMO office comes and say that give me one thing on the demand side and one thing on the supply side, which you guys need. So Shekhar, what is that simple sentence? One thing on demand side you will ask from government, and one thing on the supply side that you want to ask government on the policy side, support, Shekhar.
Yeah, actually, there are lots of boxes that need to be checked. So when you say one thing, I'm going to only tell you one thing, because otherwise this is a very long conference, right? So the one thing government can do on the demand side would be to actually facilitate purchase of the product. Either, and Siddharth said this earlier, so we are on the same track on this. Issue a PO or tender for supplying hydrogen equipment to different departments, right? And if you have to get that, let's say you want to get it at parity with the existing system, give that gap as a subsidy to the buyer, not to us, right? So that makes us competitive, because now we are competing with electrical vehicles, right? So that's on the demand side. They can create demand for us by incentivizing companies to switch to hydrogen, buy hydrogen, etc. And then there are smaller points like supply the big hydrogen cheaper, make the refueling cheaper, make the regulation to install the things. Because if I'm going to have to walk around from office to office to get every location approved, we're going to be dead before we launch this thing. Then on the supply side, we require two things. Sorry, you said one, but I'm going to say two. One is hydrogen needs to be cheap and abundantly available. We are agnostic where the hydrogen comes from. We are going to make hydrogen only because we feel this fear that the infrastructure is not going to catch up to our timeline. That's why we are doing what we're doing. So that's the one part. And the second point is, make import of equipment that we'll need to bring in initially, components initially, make that easy. It took us 4 months. We built our first three-wheeler auto rickshaw in 2021. It took us 4 months in 2022 to get it through customs. And we just sent it back because the condition was you will send it back. So we don't have a sample to show right now because we had to send this thing back. The next one is coming in March, next month.
Sure.
2 months.
Understood.
Yeah.
Siddharth, your one.
Get EEL to buy 1,000 three-wheelers per state of India and distribute it to all the government departments. So it's 29,000 vehicles. I think the business is on. That's one thing on the demand side. On the supply side is whatever equipment or whatever core that we need to manufacture these things here should come under the zero duty mechanism, single window.
Sure.
I think that's very simple. Those things
very same.
The rest of the things are work in progress. But I think EEL coming in and doing this will really make a difference. That's what EEL did with your LED lights. That's what they did also with the EVs. The initial EVs, you see all these government departments using either the Tata or the Mahindra EVs is what EEL is doing.
Yeah. Sure. I think this is a good idea, way to kind of close up. I ask Yamini to help close this, but thank you everyone. Great discussion points. There is a lot of to-dos for you guys. But at 𝗶-Manifold, we remain very, very keen to work and help evolve this ecosystem in India and global. We have earlier worked on standard side with MNRE and government. We'll be very keen to see on the testing standards facilitation side how we can ensure that the likes of ARI and others are also getting ready to be able to test, homologate the system, both ARI, PESO and others, because we are talking of the ecosystem and not just the vehicle. With that, Yamini, over to you. Thank you, everyone.
Thank you so much, Rahul, Shekhar-ji, and Siddharth-ji. I think this was really very interesting and very engaging discussion. I think a lot of things everybody got to learn from you all. And we echo your thoughts on hydrogen-powered light mobility. Thank you so much for your time. We look forward to doing more, definitely.
Thank you.
Thank you.